The selective control valves on John Deere tractors allow the operator to control hydraulic cylinders or motors on tractor implements. The selective control valve, or SCV as it's usually called, gives the tractor flexibility for using different kinds of equipment. The SCV directs high-pressure oil to remote functions. It's part of the overall hydraulic system, so understanding how it works will help you diagnose hydraulic system complaints. By watching this program, you'll become more familiar with how the SCV works. More specifically, you should be able to do the following things after watching this program. You should be able to describe SCV control lever positions and what happens to a remote function in each position. You should be able to describe the valves and mechanisms inside the SCV. And finally, you should be able to describe how oil flows through the SCV in each of the control lever positions. John Deere tractors have one or more SCVs mounted on the rear of the tractor, depending on the model and what options are installed. On the left, you can see how the SCV control lever is mounted directly to the SCV on utility tractors. On row crop and four-wheel drive tractors shown at right, the SCV control levers are mounted in the shift console. These levers are connected by linkage to the SCVs at the rear of the tractor. This diagram shows how the SCV control levers are labeled on the console. Notice that the levers are numbered with Roman numerals 1, 2, 3, and 4. Here you can see which SCVs the control levers operate. The number 1 control lever operates the lower left-hand SCV. The number 2 lever controls the lower right SCV. Number 3, the upper right SCV, and number 4, the upper left SCV. If a tractor comes with only one SCV, the SCV comes in the number 2 position. Before we go into how the SCV works, let's go over the control lever positions. The neutral position holds a hydraulic cylinder in place. It cannot extend or retract. Pulling the control lever back extends the cylinder, and pushing the lever forward retracts the cylinder. If you push or pull the lever far enough, you put it into detent, which means that the lever will stay in extend or retract position until the cylinder reaches the end of its travel. Then the control lever pops back into neutral. Pushing the lever all the way forward puts the SCV into float position, which means that a double-acting cylinder can extend or retract without restriction. The float position allows an implement to follow the ground contour. As we mentioned before, each SCV on a row crop or four-wheel drive tractor is connected to its control lever by linkage. The linkage connects to the operating arm and shaft inside the SCV housing. Notice that as the control lever pivots, it moves the operating arm back and forth, which turns the shaft. Other than this control linkage, SCVs on utility tractors work exactly the same as SCVs on row crop and four-wheel drive tractors. Now inside the SCV, the shaft is attached to a rocker assembly. The rocker assembly looks like this if you take it out of the housing. The rocker assembly is the mechanism that opens and closes valves in the SCV when operated by the control lever. Notice that the rocker assembly holds 3 cams. The 2 outside cams are called valve operating cams, and the middle cam is called the detent cam. This diagram gives you a rough idea of how the SCV would look if you stripped away the housing and other parts and left only the valves that the rocker assembly opens and closes. Those 4 valves you see are poppet valves. 2 of them are pressure poppets, meaning that they control the flow of high-pressure oil from the main hydraulic pump. The other 2 valves are return poppets, meaning that return oil from a hydraulic cylinder flows through them to the return circuit. Notice that each poppet is linked to a cam follower. As the rocker assembly turns, the cam followers move in and out to open and close the poppets. In the actual SCV, each poppet and cam follower looks like this. The spring tends to keep the poppet closed and also pushes the cam follower against the cam. Now the whole SCV is a pretty complex mechanism, so let's build one up piece by piece to see how it works. We'll start with the simple system shown here, which has 2 poppet valves, 1 pressure poppet and 1 return poppet. Right now, the SCV is in neutral. Both poppets are closed. The cylinder can neither extend nor retract. When the operator pulls the control lever into the extend position, the valve operating cams turn, and the cam followers push the poppet valves open. High-pressure oil from the main hydraulic pump flows through the pressure poppet to the cylinder, pushing the piston out. Oil on the opposite side of the piston is forced out of the cylinder and flows through the return poppet and into the return oil circuit. Notice that with only the two valves shown here, we can't retract the cylinder. The SCV needs another pair of poppets to do that. But for the sake of simplicity, we'll keep building our SCV with only two valves. So far, we've shown the poppet valves as simply open or closed. But in reality, the valves can also be opened part way, allowing a variable flow of oil. By just inching the control levers forward or backward, the operator can produce a variable rate of oil flow to the cylinder. That is, he can make the piston move faster or slower. For the sake of convenience, the operator often puts the control lever into a detent position and allows the SCV to shut off automatically when the cylinder reaches its end of travel. But the operator still needs some way to adjust oil flow to meet the demands of a particular job. The speed of cylinder movement should be slow enough to be safe, yet fast enough to be practical. John Deere's SCVs have a metering valve that can adjust the speed of cylinder movement. Here we've added this metering valve to our simple SCV. Notice that high-pressure oil flows through the metering valve first, before it flows through the pressure poppet. This diagram shows how oil flows through the metering valve. An external arm on the rear cover of the SCV controls the metering valve position. Turning the valve clockwise increases the flow rate by exposing more of the valve opening to high-pressure oil. The metering valve adjusts cylinder speed for a particular job, a particular load. But sometimes the load on a cylinder can change while the cylinder is extending or retracting, which can cause the cylinder to move either faster or slower than desired. For example, let's say we're unloading a wagon full of grain. As the box tilts higher, the grain slides to the rear and empties, which puts less weight directly over the cylinder. With less weight on the cylinder, it will extend faster and faster. And there's a basic rule of hydraulics that explains why the cylinder does that. That basic rule states that flow of oil is caused by the difference in pressure between 2 points. The larger the difference in pressure, the greater the oil flow. Now, when the grain shifts to the rear of the wagon, that lowers the pressure required for movement in the cylinder. This creates a larger pressure differential, which increases the flow of oil to the cylinder. The wagon rises faster and faster until the cylinder slams into full extension. This can be both hard on the equipment and unsafe for the operator. So we need a valve in our SCV that will keep the cylinder moving at a constant speed even when loads change. The flow control valve we've added to this diagram does just that. The flow control valve works to keep the rate of flow constant under changing load conditions. Notice that the head of the flow control valve is exposed to oil at inlet pressure from the main pump. Oil passes over the head, then through the metering valve, and back up to the center land of the flow control valve. This is how the actual flow control valve looks. The spring fits into the inner diameter of the valve. Notice in the insert that there's a small hole in the center of the valve. This hole allows pressure oil to enter the valve's inner diameter. There's pressure on both sides of the flow control valve, but the spring in its inner diameter tends to keep the valve pushed up against the valve stop. Notice the circled detail in the diagram. The valve is tapered at that point. The magnified views show that when the valve is pushed all the way to the right, it permits maximum oil flow. When the valve moves to the left, it begins to restrict oil flow. But what causes the valve to move either left or right? Notice that valve position is determined by inlet oil pressure on the head of the valve, working against force from the spring plus oil pressure on the spring side of the valve. But inlet oil pressure from the main pump is essentially constant, and the spring force is also constant. The only value that changes is oil pressure on the spring side. When that pressure drops, the valve shuttles to the left. When the spring side pressure increases, the valve shuttles right. The key to how the flow control valve works is that oil pressure on the spring side changes whenever the pressure needed to move a cylinder changes. Let's assume now that we're unloading that grain wagon with an SCV that has the flow control valve. As the wagon rises, the grain shifts to the rear, decreasing the load on the cylinder, which decreases the pressure needed for cylinder movement. As that pressure drops, pressure on the flow control valve spring side drops too. That allows the flow control valve to shuttle left, restricting oil flow. The restricted flow slows the cylinder down, keeping it at a constant speed of extension. In other cases, pressure needed to move the cylinder might increase. Then pressure on the valve spring side would also increase, shuttling the valve to the right. This increases the valve opening, allowing more oil to flow to the cylinder, again, keeping cylinder speed constant. Right now, we have a fairly flexible system. Poppet valves direct oil to and from the cylinder. A metering valve adjusts cylinder speed under constant conditions, and a flow control valve works to keep cylinder speed constant. But remember that the operator can put the control lever into a detent position, and when the cylinder reaches the end of its stroke, the lever automatically goes back to the neutral position. How does the SCV do this? That's where the center cam on the rocker assembly comes in. Remember that we called it the detent cam. The detent cam has a notch for the SCV's neutral position and two detents for full extend and full retract. In the SCV, the detent cam works with this detent piston. The piston has a cam follower that rides on the cam. The piston pin moves with the cam follower, and the actual detent piston fits on the piston pin. A spring pushes against the detent piston and holds the piston pin and cam follower against the cam. Two pin guides hold everything in place. The actual piston parts look like this, with the cam follower, inner pin guide, piston pin, detent piston, spring, and outer pin guide. Here we've put the detent piston into our simple two-poppet SCV. We show the detent cam separated from the valve operating cam for the sake of clarity. In the SCV, they're actually side by side. Notice that there's pressure oil on both sides of the detent piston, but the spring pushes it in to hold the piston pin and cam follower against the detent cam. Here the cam follower is in the neutral notch. But whenever the operator puts the control lever into a detent position, as in this diagram, the spring pushes the cam follower into the cam detent. Spring pressure is strong enough to hold the rocker assembly in that position. Now, when the cylinder reaches the end of its stroke, flow stops and pressure increases, sending a surge back through the system. Pressure builds at the front of the detent piston. Now look closely at the detent pin. Notice that on the spring end, its diameter is larger. The larger diameter reduces the surface area on the spring end of the detent piston, the end that's exposed to inlet pressure oil. The front end of the detent piston has more surface area than the spring end, so pressure oil exerts more actual force on the front. The greater force compresses the detent spring, and the spring no longer forces the cam follower into the detent cam. The rocker assembly is free to rotate, and the poppet valve springs push it back into neutral. The control lever comes back to the neutral position too. This diagram shows the complete SCV with 4 poppet valves. Notice that it takes the springs on 4 poppet valves to push the rocker assembly out of both extend and retract detent positions. Now let's review the SCV by building it from scratch again. We start with a rocker assembly, which holds the valve operating cams and detent cam. The rocker assembly is attached to the shaft and operating arm. The operating arm is connected by linkage to the control lever. The two-valve operating cams open and close 4 poppet valves. 2 are pressure poppets that direct oil to the hydraulic cylinder. The other 2 are return poppets that direct oil from the cylinder to the return oil circuit. With the SCV end cap removed, you can see where the 4 poppet valves are located. A metering valve controls the flow of oil going to the pressure poppets. The operator can use the metering valve to adjust how fast a cylinder extends and retracts. The metering valve and arm are actually fixed to the SCV end cap. The flow control valve regulates oil flow so that the speed of cylinder movement will be constant under varying load conditions. The flow control valve fits into the center bore of the SCV housing. The detent piston assembly holds the rocker assembly and control lever in detent position. When the cylinder reaches the end of its stroke, a surge of pressure comes back through the system and pushes the detent piston back. This allows the rocker assembly to go back to the neutral position. The detent piston fits into the top bore of the SCV housing. One more detail that we didn't add before is the leak-off passages. Oil can leak behind the poppet valves and the detent piston, causing hydraulic lock. These passages drain that oil off to the return oil circuit, preventing hydraulic lock. You can see these passages on the inside of the end cap. On the left, you can see how 2 breakaway couplers are built into the SCV housing on row crop and 4-wheel drive tractors. On utility tractors, at right, the couplers are mounted separately and connected by 2 metal oil lines. Before we show you how the oil flows through the SCV, remember that hoses from the cylinder must be hooked up correctly. Otherwise, you won't get the response from the cylinder you expect from the control lever position. The hose end with a small groove should be connected to the right-hand breakaway coupler. Notice that the right coupler has a notch. Now, for simplicity's sake, we'll show you only how the oil flows through the poppet valves as the control lever is put in different positions. In this case, the SCV is in neutral. Notice that all poppet valves are closed. Pressure oil cannot reach the cylinder, and return oil cannot leave the cylinder. The cylinder holds its position. In the extend position, the rocker assembly rotates and opens the lower left pressure poppet and the lower right return poppet. Notice how pressure oil flows through the pressure poppet to the hydraulic cylinder. Return oil flows through the open return poppet into the return oil circuit. In the retract position, the rocker assembly rotates and opens the upper right pressure poppet and the upper left return poppet. Notice how pressure oil first flows through the pressure poppet and then through a chamber of the closed lower right return poppet on its way to the hydraulic cylinder. Return oil flows first through a chamber of the lower left pressure poppet, which is actually closed, then up to the upper left return poppet. It flows through that poppet to the return oil circuit. The 4th position an operator can choose is float. To put the control lever into float on row crop and 4-wheel drive tractors, the operator must raise the movable stop in the lever guide, as shown on the left. Utility tractors have a stop plate that must be turned 180 degrees before the lever can be put into float. Inside the SCV, putting the lever into float causes the rocker assembly to rotate past retract detent. The cams are shaped so that in this position, they hold only the 2 return poppet valves open. The 2 pressure poppets stay closed. Notice how both sides of the double-acting cylinder are now connected to the return oil circuit. The cylinder can extend and retract freely, allowing an implement to follow the contour of the ground. Well, now you've seen how the SCV works. But there is one other thing you should be aware of. If you connect a single-acting cylinder to a row crop or 4-wheel drive tractor, use the lower right-hand SCV if possible. Connect the hose to the left-hand coupler. A directional control valve behind the number 2 SCV allows the cylinder to retract faster. That concludes this program on John Deere selective control valves. By now, you should be able to do the following things: describe control lever positions and what they do, describe the internal valves and mechanisms of the SCV, and describe how oil flows through the SCV under various conditions. This knowledge will enhance your ability to diagnose hydraulic system problems. If you've had problems with this material, you should consider watching this program again. You can also find additional reference material in the Operator's Manual, Technical Manual, and the Fundamentals of Service Manual on hydraulics. If possible, take the time to operate the SCVs on a tractor and disassemble a selective control valve.